This is problem number 9 from chapter 6. Thuy Doc, Nak Bu, Sam Su, and Lan Wong conducted a survey as to how long customers at Lucky's claim to wait at the checkout line. So the random variable x is the time in line. So below the order data already set up in order in minutes. Calculate the sample mean for the sample. Calculate the sample mean and sample standard deviation. So I've inputted all this stuff in the calculator, and we're just going to go to stat, calc, 1var stats, and we're going to do the 1var stats on L1. And here we have our information. We have x bar equals 5.51, and the sample standard deviation, remember, is S, and that is 2.14, 145 or 146, 2.146. Let's just take a copy of that. So the next question, construct a histogram starting at the x-axis at negative 0.375. So the idea behind that is to put a 0.375 in the beginning, and then it has a width of 2, so the next level would be 2 plus this, and then it'll keep going that way. So we have our calculator. We can go to stat, or the stat plot, which is the second function in the y equals 2, gives you the stat plot. And we'll select 1. It's already on. We're going to go to the next one. It says type. And then we're going to select this icon, which is the histograms icon. And then we're going to get our data from list 1 with the frequency of 1. Now before we go on, what we're going to do is we're going to set up our window. Let's try that again. Let's set up our window. And we're going to start our x min at negative. So remember the negative sign for the calculator is this one, negative 0.375. Our x max goes all the way up to 10, so let's go a little bit past 10, like 11. And then our x scale, this is the important part. This has bar widths of 2 minutes, so we're going to put 2 here. That's our class width. Our y min, we want to go from 0, but if we can go down a little bit lower, negative 3 sounds fine. And then if we imagine how these things are going to stack up, there's a few of them that have 4 or so. So maybe I'll select the y max of, let's start off with 10, and if we need to change it, we'll change it. So let's go ahead and graph this. Okay, so 10 didn't seem to be enough, so I think I'm going to go and put that a little bit higher. So let's change our window, and we're looking at y max here, and let's go 15, maybe just 20 to make sure that we catch everything. So let's hit graph. Looks like our x didn't go quite all the way to a little bit past 11, so let's adjust that also. And let's take a look at x max, and instead of going 11, maybe just go all the way up to 13 just to be safe. Okay, so this is our distribution, or this is our histogram, and let's see if we can put this histogram over here. Well, I guess it doesn't want to go next to it. Let's put it over here. It says to make up a histogram and draw a smooth curve through the midpoints of the tops of the bars. So if we have midpoints of the tops of the bars over here, so a smooth curve kind of looks like that. Now it'd be interesting if we can take a look at that curve and see how it looks like. And if you can just imagine how this thing is going to flow, it looks pretty symmetric. So I'd say that this curve is symmetric, or even bell-shaped, as we would call it. So this is actually a good candidate for the normal distribution. So let the sample mean mu and the sample standard deviation, let the sample mean approximate mu and the sample standard deviation approximate sigma. The distribution of x can be approximated by the distribution is going to be a normal distribution, and our sample mean, if you remember, was 5.51, and our sample standard deviation was 2.146. Okay. Now they say use the distribution to calculate the probability that one person will wait fewer than 6.1 minutes. Okay, for this one, it's back to the normal distribution problem, so this is going to involve a normal CDF. Fewer than 6.1 minutes will, let's see, it's better, I guess, if we start off with that bell-shaped curve, which is approximating our histogram. The mean was 5.51, so 6.1 would be to the right of that, and fewer would be this region over here. So we should be looking at the area to the left, and just by looking at this picture and assuming that the area under the whole curve is 1 and an area cut in half is half, this should be bigger than 1/2. So let's take a look at that. Our probability that x is going to be less than 6.1 minutes, and on the calculator we will be using the normal CDF function. Our low is going to be, we get negative there, and really you can't wait negative time, but theoretically that's what's really happening. And then more theoretically, this thing goes all the way up to infinity, and if our symbol for infinity is e, or 1e to the 99. Our maximum, or our high, would be 6.1, and then we'll tack on our mean and our standard deviation. Okay, so let's punch that in our calculator. We get that by going to second function in bars. Normal CDF is the second one. And then we have a 1. I'm sorry, it should be a negative. So let's go -1. And the second function, comma, give you that E symbol, 99. And 6.1. And 5.51 and 2.146. Let's close the parentheses, hit enter, and we got a value that's bigger than 1/2 like we anticipated. So this is 0.6083. The next problem is asking us to determine the cumulative relative frequency for waiting less than 6.1 minutes. So if we take a look at the cumulative relative frequency in our frequency table, 6.1 minutes would be We didn't put the tick marks over here, but let's go back to our graph and let's hit trace. And this gives us our first box over here with a minimum of negative 0.375 and a maximum of 1.625. If we go to the next block, we go all the way up to 3.6, 5.6, and this one gives us 7.625. So we can approximate this by adding all these numbers up to 17. But the other thing that we can do is take a look at our graph. Here we go. And look at 6.1. 6.1 would be somewhere over here. And we have 10, 20, 32. So the relative frequency there would be 32. That's all the values that's less than 6.1. And then the total number of values we have is 50. So if we check that in our calculators, let's punch that in. That would be 32 divided by 50. And then we got 0.64. Why aren't the answers exactly the same? They're not exactly the same because we're using, for the first one, the normal distribution. To approximate the probability or relative frequency. And why are they so close? Because what we're doing is we're essentially finding out all those values. That's less than 6.1. Finding the exact frequency based on our data would be looking at the bar graphs, and finding the approximated frequency using the distribution would be using the area under the curve. Well, it looks like the area under the curve, our bell-shaped curve, mimics our bar graphs pretty closely, our histogram pretty closely. So I think that's why we have a good approximation. Now the last one, if only 10 customers surveyed instead of 50, do you think the answers would have been closer or farther apart? So I think for this one, it should be probably farther apart, since the more data you have, the closer you'll be to the approximation. And if you have a larger amount of data, you'll be a lot closer to the bell-shaped curve. If you have less data, you'll be farther away. So less data, not so good approximation. Okay, so I hope this helps with your homework.